Okay, so for the law of sines, some of you have asked, for a couple of people have asked for some help with this, said they're a little lost, not quite understand this whole two possibilities or one possibility or that kind of thing. For example, actually, I can look right in the ebook. So here they talk about state whether there's 1, 0, 1, or 2 triangles. And they give us all these sides, and it really doesn't look like it makes much sense. So what I want you to think about, and I'm hoping you studied this in high school geometry when you did that. People, I know these days, it seems to be like proofs seem to be something that people hate. And triangle, one reason why you studied whether or not triangles were congruent was because of what we're going to do with this law of sine, law of cosine stuff. So you learned, I'm hoping you learned that if you have two triangles and you know all three sides are congruent, that locks in, there's only going to be one possible triangle if you have a side. And if we have a side angle side, well, this is going to be a situation where we're learn you have to use a law of cosines. And that's what's coming up in the next lesson. If we have a angle side angle situation where they give you two angles with the included side, that's a law of sines because you can subtract those two angles from 180, find the sum of those two angles, subtract that from 180, and that'll give you the third side, or third angle, and then you get an angle side pair, and you can figure that out. So there's only one triangle, and most likely there'll be a solution with that. The same thing with angle side, and here's a perfect law of sine situation where you have a side, an angle in the opposite side. Okay, and that'll let you find the other side. So law of sines, great law of sines problem, great law of sines problem. Need the law of cosines for this. I think we need the law of cosines for this also. So that's if you know you can solve a triangle if you know angle side. I'm sorry, angle side or angle side angle. You can use a law of sines and solve it no problem. What gets messy is this. When you have a side angle, and if we reverse that, you might remember some funny discussions in algebra or in geometry about why those aren't. Why, if you try to show that a triangle is congruent when you have a side pattern, that you can't do it. That's not a triangle congruence postulate. So there's a couple of things that can happen when you have a angle side situation. As you can see with this one, there's no triangle being formed. So if we even tried to use the law of sines for this, here, let me pull up a whiteboard here, and if I try to set up the law of sines for this, let's see, this book uses the sides on first. So 4.7 over the sine of 38 equals 9 over the sine of, let's say we're looking for this angle here that doesn't exist. Okay, well, we'll call that sine A. Sine C, doesn't really matter. If I try to solve this, I'm going to do 9 times the sine of 38 divided by 4.7. See, if I didn't know this, I didn't know that this was going to not be a triangle, what's going to happen is, let's see, let me quit this. So that's one thing. I'm hoping this came to you last semester when you were learning this material. If I do mode, if I'm using a graphing calculator and you're working with the law of sines, law of cosines, you want to be in degree mode. So if you press mode and then come down and make sure the degree is dark and press enter, now you're in degree mode, right? So I'm going to quit this. So I'm going to try to calculate this. 9 times the sine of 38 and I'm going to divide that by 4.7. And as you see, I get a number bigger than 1. And if I try to do the arc sine of that, I'm going to get an error because the maximum value the sine can take is 1, right? So right there, that tells me, yeah, there's no triangle possible. And I could really do that without even, without even knowing that this, if looking at this graph or this GeoGebra applet, there's no triangle possible. And that's what's going to happen. So if you're trying to solve this and you set up the law of sines and you have to find an angle, then you know, and you get a value bigger than 1, you know there's no triangle. So then what can happen if we extend, let's see, what am I going to do? I'm going to change this angle a little bit. I think I can change side A too. Let's just change side A. Let's see, actually, here. There we go. Let's not make it so big. There we go. So here's a situation where there's 2 triangles being formed, and that's the ambiguous case. And this is why the angle side angle is not a congruence postulate, because there's not 1 triangle that can be formed. There's 2 possible ones. So that's why we throw that out. So how do you solve this? Well, there's 2 possibilities. If I set up my, let's see, where's my applet here? If I set up the law of sines for this, let me clear this out. Whoops. Nope, that's what I wanted to do. Here we go. If I try to set up, if I say 6 over the sine of 38, and I say, if I'm looking, what do I know? I know if I'm looking for measure of angle B, right? If I do 9 over the sine of angle B, and I try to use my calculator with that, let's see, so I'm going to do 9. Here, let me clear this and clear that key press history. So I'm going to do 9 times the sine of 38 divided by 6. I get a number, I get a number that's less than 1. I can do the arc sine of that. So second sine, second answer, and I get 67 degrees. So I think, hey, there's only 1 answer. Well, because this is a side angle, and you can kind of see what's happening with the sketch, it looks like there's 2 possible triangles. So that tells me there must be two angles that have that same sign. And what I want you to think about is on the unit circle, here's that 67 degree angle, 67.4 degree angle. Well, where else in this unit circle, where is the sine going to be equal to the same value? Where is that y going to be the same value? Well, that's going to be over here in quadrant 2. And where the reference angle is 67.4, and it just so happens there's the other angle. And that's just going to be 180 minus the 67.4. And do they show us that in that sketch? Well, they don't show us, but that's that obtuse angle that we just found. And so then if you're going to list all the possible solutions, well, you gotta worry about that. If you wait a minute here, so that's when you know there's two angles. You gotta. I would highly recommend. I mean, that's not to say if you have a side angle, there's not going to be two triangles, but usually there is. Where was I going to go with this? Okay, so I guess that's how you can tell whether there's 2 triangles. You got to check them and see. So let me stop this, and in that quiz I'm going to ask you to do, or if you're a CCV student watching this, there's one of the homework assignments that you have to do with this, and I should walk you through that.